Hi, my name is Jonathan Patelis Hemmers, and my experiment is called the cold ray experiment. In scientific terms, this name is thermodynamic equilibrium of black body radiation. My question was, do cold rays exist? Which I asked to my dad a lot when I was watching movies where the characters use freeze rays. I wanted to see if freeze rays do exist. My hypothesis is that they do exist, based on what I know about temperature. Whenever something cold is near a thermometer, I saw that the temperature on the thermometer always dropped. And also what I knew about rays. I knew that you could concentrate a ray with a parabolic mirror, which is right here. An example of using a parabolic mirror in real life is the headlights of your car, which uses parabolic mirror to concentrate the light into one beam. My scientific principles were thermal radiation, black body radiation, radiative equilibrium, and absolute zero. Thermal radiation is heat radiation. A black body is any matter that absorbs and emits radiation at all wavelengths. Black body radiation is when a black body emits radiation. Radiative equilibrium is when a body and its environment emit the same amount of thermal radiation. And absolute zero is a temperature at which all molecular movement stops and no thermal radiation can be emitted. This temperature is negative 459.67 degrees Fahrenheit. My materials were the parabolic mirrors, the cement tubes, the duct tape, the bolt, the nuts, the washer, the tube, the putty, the hot water, the cold water, the dry ice, the crushed ice, the paper towels, the ruler, and the digital thermometer. What we did to do the experiment was we used all the materials over here to build this setup, which is this. To do the experiment, you unscrew the tube, and I'm going to use dry ice as this example. You put the dry ice into it, you take the temperature and record it. Then you screw it back in and put the other parabolic mirror on. Wait for 5 minutes, record the temperature, and wait for 10 minutes, record the temperature. Take the tube back out and record the temperature again. My results were in this graph, In this graph, which shows the 12-inch and 6-inch tubes for the thermometer temperatures. The sample is what we put in the tube. Initial sample temperature is the temperature of the sample that before we put it in the tube. The final sample temperature is the temperature of the sample after we put it in the tube. The thermometer after 5 minutes is what the temperature was inside after 5 minutes. And the thermometer after 10 minutes is what the temperature was inside after 10 minutes. This all applies for the 6-inch cement graph. Then we converted the temperature from Fahrenheit to Kelvin, which is another scale of temperatures. To convert that, you do the temperature in Fahrenheit minus 32 divided by 9 times 5 plus 273.50. We found out that cold rays do not exist from this graph over here. How we did it is that we saw that the 6-inch tube and the 12-inch tube lines were almost identical and that they formed an almost straight line. This is an indication that thermal conduction, which is where you conduct heat, and thermal convection is where you use a fan to blow around heat, can be neglected, and that the interaction between the two mirrors was all thermal radiation. This means that what I observed was a lack of heat reaching the thermometer tip, which means that cold rays do not exist and that all radiation is thermal. I would like to thank my mom and dad for helping me with everything that they did. No, for helping me with everything that I did in the science.